Okay, guys, welcome. So today we are going to cover this topic, which is about the determination of the rate law. So basically, this is one of the simplest concept that I have ever come across as far as this module is concerned. So now, suppose that we have the rate law for the, reaction A, which is like this one here. You can see we have V for the rate and K for the rate constant and the A or capital letter A in brackets for the concentration of A to the power P or a letter P, which of course in this case, just because of the position, can you see it's on top with this P, is the rate order or the order of the reaction. So now then the initial rate will be V0. Remember I said this V is the rate, of the reaction. So now, given the initial values of the concentration of A, we can then write V0 is equal to K multiplied by the concentration of A0 or the initial concentration of what? Of A, because A, that is in square brackets, the square brackets just denote that this is the concentration of the letter A or concentration of the reactant A. The 0 simply means that this is the initial what? The initial value. We are talking about the initial value. That's why we are including these zeros to the power P, whereby P is the rate order. So now, taking the logarithmic of this part, and remember, why do we have to take the logarithmic part other than just going straight right away and solve problem, because mathematically if we have other values and we need, let's say, of P and we have V, K and A, obviously we can substitute and directly find the value of P and rearrange them there. But we'll need logarithmic specifically because there are case or situation whereby you will find that you are only given V0 and also A0. So you are given maybe the concentration and also the initial rates, but you are not given the rate constant, you are not given P. So in other words, out of these four parameters, you might find that you are given two and the two are not provided. So there is a simple way to solve a question of that nature. What we do, we introduce logarithmic function. You will realize that if we take a log of this equation, we're going to have something like this one. We're going to have log V0, this is the one, log V0, which is equal to log of K plus P log of A0. So that's what the logarithmic equation will be like for as far as this equation is concerned. But then let me rearrange this equation nicely for you. If I were to rearrange this equation, you will realize that this equation, this one, is the same equation with this one here. The only difference is that I swap these two. I put this one on this side and then this one I put it on this position here. So why did I do that? I'm doing that specifically to show you that this expression now, it's more like the straight line equation, whereby it's more like y is equal to mx plus c, whereby this y will be will be replaced by log v0, and m will be replaced by what? By this a p here. It's supposed to be p, not a here. This one here is supposed to be p, the same p as this one, right? So this one is p. Let me write it. Let me get the pen and write it. So this one is not a, it's p. Let me write p. Yes, the same p as this one. So in other words, this is the one. So it's log v0 for this one is equal to p, which is this one. Yeah, let me get the pointer so that I can be showing what I'm talking about. Yeah, so it's more like this. P is this one, log A0 is this one, right? Plus log K is the same log A as this one, and log V0 is the same log V0 as this one. So in other words, if this equation I'm saying is the straight line, this simply means that this C here, it correlates with what? With log K. And this X here, it correlates with log A0. So in other words, if I can just get my pen, I will write it in this manner. I will say Okay, I will say this log here, log A0, is exactly the same as what? As this x here, right? And then this log V0 here, this one, log V0 here, it will take the position of what? Of this y here, right? So that if you were to plot a graph, we will just have the Cartesian plane, our Cartesian plane ready like this. So this simply means that in a position of x, we are going to write what? This one here, which is what? Log of A0. That's what we are going to write in the position of x. In the position of y, this is what we are going to write. We are going to write what? Log V0 in the position of what? Of y. So this simply means that in a series or for a series of initial concentration, like for example, if you are given a series of the initial concentration, of course, together with the initial rates, then you can now just substitute and introduce log like this table here. Let me get my pointer also again to show what I'm talking about. So now, if you are given a series of initial concentration, this initial concentration here, and initial rates, then you're just going to introduce what? The log. And doing so, you will realize that you can now plot a straight line graph whereby this is your x-axis and this is your y-axis, and then you can plot a graph whereby you can also find what? The gradient from what? The graph. So in other words, if you check here, you will realize that gradient is what? Is a, or it correlates with a. So this means m for gradient is y2 minus y1 is equal to x2 minus x1. This is exactly the same, or the value that you are going to get here is exactly the same value of what? Of a, of p, which is what? Which is going to be your order of the reaction, because you can see that p is at this position here in our initial equation, which is the position of what? Of the order of the reaction. So thank you.